That's okay. All right, so we got survey. There's two other main types of ways that we can collect data and we can find stuff out. We can try to figure out, hey, does the one that came up a long time ago, does smoking cause cancer? And there's two ways that we might could go about that, right? Maybe we want to figure out, does vaping cause cancer? And possibly it does, possibly it doesn't, but there's two ways we could do that. The first way is an observational study. In an observational study, researchers are simply observing. Researchers are simply observing. That's it. They're not touching anything. They're not dictating anything. They're not putting people into groups and say, hey, you guys are going to smoke vapes 5 days a week, and this group over here is not going to smoke vapes at all. Like, we're not doing that. Maybe we find people that vape, say, hey, have you had any issues with your lungs? Have you had any issues with going to the doctor? And we just follow those people and we say, hey, maybe there is a connection between coffee and cancer, right? Like, there's all these connections these researchers are trying to make, but all they're doing is observing. They're not doing anything else, really. So they're simply observing, and they do not influence responses. Do not influence responses. They do not influence responses. One way to think about this is an observational study. We look, but we don't touch. We look, but we don't touch. We don't change anything. We don't dictate anything. We're just simply observing. We're looking at medical records. We're saying, hey, do you, we go find somebody, hey, do you drive a car? Yes. How fast do you go? And then you just simply observe how fast they go. You don't do anything else. All right, several key steps involved in designing an observational study. A lot of times I just like to type this stuff up, so it saves us a lot of time in class. One, we got to determine what we're trying to study. Okay, what are we trying to figure out? And what is the variable of interest? And what information is needed to answer the main question of interest? And we're going to see a couple examples today, and we're going to talk about that variable of interest today. We're going to develop a plan to collect data. You can't just, well, I want to know if drinking sodas causes weight gain. Well, you got to develop a plan to figure out who drinks soda and how are you going to weigh these subjects and how are you going to determine, like, you got to come up with a plan for all that kind of stuff, right? And how will subjects be observed? And we're going to see some examples of that today too. Determine the most appropriate sampling method and select the sample. If we're sampling, we can't do the entire population like soda drinkers. How many people drink soda? A lot. Are you going to be able to ask everybody that drinks soda if they've gained weight just because they drink soda? No, you're not. So you're going to have to develop a sample, like a random sample or a systematic sample or a stratified sample, the ones that we talked about yesterday and earlier today. And then you're going to collect the data, and then you're going to describe and interpret the data using appropriate statistical procedures and graphs, and then report the findings of the study. So a lot of times it's unethical to try to manipulate people. Like, hey, do you drink soda? Maybe soda drinkers would be a little different, but like vaping, you can't go and say, hey, you 20 people are going to vape and you 20 people are not going to vape, right? That's unethical. So that's something you would simply observe. And experiment. You do those in science all the time, right? We're going to talk about those as part of like statistical experiments. And what happens? Researchers gather data. So now they're not just simply observing. We are still gathering data by imposing a treatment. So researchers are gathering this data by imposing a treatment. So maybe like you did a science fair project maybe, and you wanted to know, does music affect the rate that plants grow? So then you take one plant and you play music right next to it for 7 days. And you take another plant and you put the other plant over here in a different space, and you don't play music next to that plant for 7 days. So now you're imposing a treatment, playing music versus not playing music. And that's something that you can actually do. It's not something you're simply observing. So researchers gather data by opposing the treatment. And in this case, we said earlier, look, but don't touch. Now we're looking and touching. Okay, we are manipulating our treatments. So manipulation here is required. Manipulation required. With an observational study, you cannot manipulate anything. You can't tell people what to do. You can't put them in groups. You can't do anything like that. You just simply observe. You go stand up at the front door. How many students today are wearing t-shirts? Right, you just go stand at the door and you just observe as they come in. Hey, I have this many students who are wearing t-shirts today. The basic principles of experimental design. It has to be random. If we're going to put, let's say we have 40 people, we're going to put them in 2 groups of 20. Those groups have to be randomly selected. Which 20 go in this group and which 20 go in this group, completely random. Which 20 get the medicine and which 20 get the placebo, which they think they're taking the medicine, but they don't know it's not the medicine. Control. Experiments need to control any lurking variables, generally by comparing multiple treatment groups. So maybe in science class, you talked about the control variable, like what's not changing, like the 2 plants. We talked about the plant with music and the plant without music. What should they always get? They should get the same amount of soil, the same amount of fertilizer, the same amount of sunlight, right? And if they're not getting those things equally, then maybe it's the sunlight causing the extra growth versus the music. Maybe it's the water. Maybe we gave this one more water. We gave this one less water. So the one with music's not going to grow as much because we didn't give it any water. So we have to control those things that we're not trying to test. And replication, your experiment should be able to be replicated over and over and over. I should be able to look at your procedure from your science class, and I should be able to replicate your experiment exactly the same way you did it, and I should be able to get the same results or similar results that you got. So a couple examples. Use the information. Is it a survey, right? It's probably not going to be a survey since that's not part of our notes, because survey is kind of pretty common knowledge. Is it an observational study or an experiment? Let's start there. A local community has just installed red light cameras at its busiest intersection. The police department hopes that the cameras will encourage drivers to be more careful, that incidents of drivers running red lights at an intersection will decrease. Do you think it would be best to do this with an observational study or with an experiment? Can we control who goes through the red light? No, not really. Can we put them in groups? Like these 20 cars are going to go through the intersection with the red light camera, and these other 20 cars are going to go through without a red light camera. Well, we probably can't do that. So an observational study would be best in this case. So what we want to do, we want to design an observational study that the police department could use to determine if the installation of the traffic light has had the desired effect. The installation of the traffic camera has had the desired effect. Okay. So what is our focus of study? What are we trying to figure out in this case? What are we trying to figure out in this case? We're trying to figure out if red light cameras reduce people running red lights. That's what we're trying to figure out. If we put a red light camera in there, is it going to reduce the number of occurrences that people go through that red light when they're not supposed to? And what can we actually measure? We need something that we can measure. What is the variable of interest? Maybe right here by 1828 Coffee. That seems like the busiest intersection in Pike County, at least in the mornings. To me, maybe we put a red light camera there. If you were standing there on the corner, what could you count? What do you actually stand there and count to help us in this situation? Any ideas? You could actually count the number of cars that run the red light, right? That's something you could count. Oh, that car just ran the red light. That car just ran the red light. That car just ran the red light. So our variable interest is the number of cars running the red light. Number of cars running the red light. So now we're setting this up. We're getting where we need to be. Maybe the camera, maybe we don't have to go stand up there, because with technology, maybe the camera is going to take a picture of all the cars that run the red light, and it's going to timestamp it. So then maybe we just go look on the computer. Hey, how many people ran the red light between 7 a.m. this morning and 9 a.m.? Because that's when it's probably the busiest for school traffic. How many people ran the red light between those two times? You could probably pull that up on the computer today. Determine the data collection plan. How are we going to collect data? How might we collect data? Remember, we're trying to figure out if the red light camera is affecting the number of people that run the red light. So what might we need to do? We need some baseline data. How many people run the red light before we put the camera up? Does that make sense? So what might we do? We need to collect data prior. So collect data prior to the installation of the camera. So collect data prior to installing the camera. Now you can go back, like obviously you can't do that with technology, because technology is not going to tell you who ran the camera or who ran the red light, because you don't have the camera there anymore. So you might need to actually go stand or sit close to the red light and observe how many people run the red light that day, or for over the span of a couple weeks, maybe. And then what do we also need to do? We collect data prior to installing the camera. We're going to install the camera, and then we're also going to collect data after the camera has been installed. So we're going to collect data after installing the camera. And then once we do that, we collect the data before, we collect the data after, then we might compare those two. Hey, 5 people ran the red light each day before we installed the camera. Only 2 people ran the red light after we installed the camera. We might be able to say, hey, maybe the camera did have an influence on the number of people running the red light that day. All right, part C, funds are limited. It seems like that's the theme lately. Like, hey, we just don't have a whole lot of money because everything costs a lot these days. So funds are limited. There are only a few days to conduct the study. What is the most appropriate sampling method? Talked about this yesterday a little bit. What's the most appropriate sampling method that we talked about yesterday? Not a trick question. The most appropriate is a random sample. It's a random sample. And how about we use a random sample? So if we're going to go observe, we might randomly pick what times we actually observe the red light. Because if we go up there when it's the busiest, there's probably going to be more people running the red light if it's really busy that day. If it's not that busy, there's probably not going to be a whole lot of people running the red light. So if we randomly select what times we go stand and watch and observe. All right, part D, the police chief also wonders if there's a difference in driving behavior at different times of the day. So now we're not just interested in the red light camera, but we're interested in like school rush hour versus 10 o'clock. I don't imagine there's a whole lot of people at 10 o'clock in the morning going through the red light up there by 1828 coffee. But how many people are going through there between like 7:15 and 8:30? A lot, right? Because they're trying to get to school. So what can we incorporate this concern into your sampling method? So now we're talking about different times of the day. So now maybe we've grouped the day. We've taken the day and we've grouped it. So now we might use instead of using a random sample, we might use a stratified sample. And what are some ways that we might group the day? Like we want to know different times of the day. You could do one example. You could do morning, afternoon, and evening. Morning, afternoon, and evening, and we could randomly select 2 hours out of each of those times. So 2 hours in the morning, 2 hours in the afternoon, and 2 hours in the evening. We could randomly select those. Other examples that I thought of, maybe you could do like heavy commute times, and light commute times. Like you would have to know when those heavy commute times were, like school hours, or right before school drop off, maybe right after school drop off in Pike County anyway. And then maybe you could break the day down into maybe you could break it down into hours of the day. Like that's a lot of breaking it down, but these are just 3 different ways that we could break this down. So we break it down to hours of the day, and then maybe we pick like 10 minutes out of each hour that we're going to observe the traffic light. But since we're picking from each group, that would be stratified. All right, cool. Number 2, I like number 2. A few years ago, a study was conducted at Johns Hopkins Hospital in Boston to see if exposure to ultrasound could affect the birth weight of a baby. Now, is this something that a researcher could go, we're looking at like observational study versus experiment in this case, which one would be best? Could a researcher go up to a mom, a pregnant lady, and say, hey, you're getting an ultrasound, but you're not? Does that seem ethical? That doesn't seem very ethical for a researcher who has no medical background knowledge, probably, outside of like not caring for that expectant mother. That's not very likely. So in this case, an observational study would probably be best. So let's keep going. Investigators followed unborn babies and their mothers until their birth and notes their birth weight. Notice they didn't put them in groups. They didn't do anything to affect the outcomes, but they are looking at those mothers that were used with an ultrasound and the ones that did not use ultrasound. So they are comparing those 2 groups, but they did not put them in groups. Who put them in groups? Who determined if they were going to use ultrasound or not? A comparison was made between the birth weight of those babies exposed to ultrasound and those not exposed to ultrasound. So it kind of sounds like an experiment, but the researcher, the investigators are not putting them into groups. Whether an ultrasound was used on a baby was a decision made by the mother's doctor. So the doctor made the decision. The investigator had no control over that. So the investigator's just looking, just observing, not manipulating anything. Was this study an experiment or observational study? I think we answered that question. Observational study. Why is it an observational study? It asks you to explain it. You don't have to write the explanation down at the moment unless you just really want to. But 1, the groups were determined by the doctor, not the investigator. That's one reason. 2, the investigators are only observing. The investigators, the researchers are not manipulating anything. They're not saying, hey, these 20 are in this group, these 20 in this group, these are going to get ultrasound, these are not. The investigators aren't doing that. And there's also no randomization. It's not random what person went in each group. The doctors are determining that. All right, and this other word that we need to be aware of is confounding variables. What are confounding variables, or what is a confounding variable? A confounding variable is an extraneous variable or an extra variable. Just abbreviate that word. An extra variable that researchers did not take account for. An extra variable that researchers didn't take account for. That might also affect, in our case, the birth weight of these babies. The birth weight of these babies. So the only thing the researchers are looking at is ultrasound, not ultrasound. So what would be some other things that might affect how much this baby weighs when it's born? other than ultrasound and not ultrasound? Genetics, perfect. Maybe, and we could put mother and father genetics in that case. The genetics might affect the birth weight. What are some other things that might affect the birth weight? We would call these confounding variables.
Or the mom.
The mom's diet. So the mother's diet. Good, perfect. They didn't take that into consideration. They're only looking at ultrasound and not ultrasound. Anything else we can think of? I think y'all are on the right track. Genetics, mother's diet. I'm gonna put mother's lifestyle. Mother's lifestyle. That kind of encompasses a whole bunch of things. Does the mother work out? Does the mother do drugs? Does the mother smoke? Just anything dealing with that mother's lifestyle. What about the mother's age? Mother's age, it may not affect it, but it might. I don't know, right? The age of the mother. What about the, and we might have kind of included this in the, there's one more that might affect the birth weight. It's probably really big. If a baby's born early, they're more likely to weigh, we would think that, right? So maybe we would call this the term length. So maybe the term length, they're not looking at that either. So how long did the baby stay in utero? Lots of medical words there that I didn't know before I had babies. That's okay. All right, cool. So that's an observational study. Suppose the faculty of a statistics department at a large university wanted to look at how students in the introductory statistics courses might perform on exams under different environmental conditions. Okay, we're talking about classroom size here. So large classrooms and small classrooms. Would it be unethical to separate students into a large classroom and a small classroom? Not really. So could we do this with an experiment? Like, hey, we got a test coming up. I'm going to randomly select 20 of you to go to the large classroom, and I'm going to randomly select 20 of you to go to a smaller classroom. And at the end of the day, we compare the two groups' test results. So in this case, an experiment would probably be best. So they decided to consider the effect of the size of the classroom. A smaller classroom where there are just enough seats versus a large classroom where the students can spread out. When the next exam is given in one section of the statistics course, 60 students will be randomly, that's really important, assigned to one of the treatments. The scores on the exam will then be compared. So is this study an experiment or observational study? It is an experiment. Why is it an experiment? Because whoever is doing the research is manipulating the two groups. They're imposing this treatment of smaller and larger classrooms, and they're manipulating who goes into which one. So it's definitely an experiment. So a good explanation for that would be subjects randomly assigned to treatments. Randomly assigned to treatment groups. Subjects randomly assigned to treatment groups. The explanatory variable. The explanatory variable is what we're changing. So what are we changing with the two groups here? The size of the classroom, so classroom size. You could also call this, maybe in your science class, you would call this the independence variable. The explanatory variable and the independent variable are basically the same thing. And what is the response variable? What are we collecting data on? The test scores. So the response variable would be their test scores. And in science class, you might call this the dependence variable. You might call that the dependent variable. How many treatments are in this case, or how many groups are we experimenting with? 2. What are those treatments? Bigger and smaller classrooms. So there's 2 treatments. We have large and small classrooms. That would be our 2 treatments. We're going to put them in different classroom size. We're gonna put one group in a large classroom, one group in a small classroom, same number of students in each classroom. So we're kind of controlling that idea. They're taking the test on the same day, so we're controlling that idea. I've already diagram a completely randomized design for the study. So it's going to look something like this. So 60 students. That's our that's what we're looking at. Those are our subjects of the experiment. And what are we going to do with those 60 students? We're going to split them into two groups. Which groups are we splitting them into? We're splitting them into a large classroom and a small classroom. So half of them are going to the large classroom and half of them are going to the small classroom. How are we going to determine which ones go to the large classroom and which ones go to the small classroom? Randomly, right? So this is going to be random. So let's write that word in here. Random. And then after they take their test, what are we going to compare at the end of the day? We're going to compare their exam score. And we will finish the rest of this on Monday, I guess. There's two more examples. They're exactly like the one we just did for the most part. But we'll finish those on Monday. And then we will let you guys read some scenarios and determine if an observational study, an experiment, or a survey would be best. And that'll be your classwork on Monday. And that's probably all we'll do on Monday, honestly. So good work. We'll finish the notes here on Monday. And unfortunately, I'm going to read the handbook to you. Hopefully finish it